on what we Are there any questions on what we've done up to this point with chapter 5? Some of you are going, yeah, I just need to get back in the swing, took a week off. Some of you are good to go. Some of you are going to panic when I say next Wednesday will be our next test. We're going to do 5, 6, and 6.1 today. Do a little more work with chapter 6 on Wednesday and on Monday. And then next Wednesday will be our chapters 5 and 6 test. That means all we have left after that is the 4th test, which is the final exam. And that'll be on a little bit of everything, but mainly chapters 7 and 8. Okay, so I have the half angle identity title here with my mediocre handwriting. And I have something we already know, this guy, because we derived him from the cosine of theta plus theta. And we went through and you know, just like over here, the sine had one choice. The cosine actually had 3 choices. And we looked at verifying an identity and we said, oh, I want to pull this out and put one of these in, but I wasn't sure which one to put in and so forth. And eventually you would have gotten to the same place. But we're going to start out with the cosine of theta equals 1 minus the sine squared. And just like we derived these from these up here, we're going to derive half angle formulas from this group of identities over here. So taking a look at this first one, hopefully you've had time to write it down. I'm going to say to you, I'm going to pause for about 2 minutes. I want you to solve for the sine of x. I want you to get the sine of x alone. And this goes back to, you've seen it here and there in algebra 1 and pre-algebra where it says solve for t, and you had this crazy formula and you had to get t alone. But what I'm going to ask you to do right now is get the sine of x alone. So I'm going to pause, just work on your own. So let's see what I've done so far. I subtracted 1 from both sides. Didn't like the negative, so I multiplied everything by -1. Lots of legal algebra things we've done from a long time ago. Took these two and rewrote them just because it looks a little smoother. Divide everything by 2. And I'm going to take the square root to get rid of the 2. Plus or minus the square root of 1 minus the cosine of 2x all over 2 equals the sine of x. All right. I hope that some of you, in fact, got that. We were able to say, okay, that's the sine of x. Now, why did I do all that? Well, I'm going to go back to my original statement that we want to work with half angles. So what I'm going to do right now is a little quick substitution, and I'm going to say, how about we let x equal theta over 2? So wherever there's an x, I'm going to put theta over 2. So it looks like I'm going to be left with plus or minus 1 minus, okay, so that's going to become 2 times theta over 2. I'm going to replace the x, do a substitution, and throw in theta over 2. So 2 times theta over 2, come on, gives me just a theta. 1 minus the cosine of theta over 2, make it look pretty, equals the sine, and again, I'm replacing x with theta over 2. And now I'm going to go, woohoo, because I got this, and all of you were like, yes, this is so cool. I'm so glad I came today. Glad to be back, and I am ready to roll. And what I just came up with was this fella right here. The sine of theta over 2 equals plus or minus 1 minus the cosine of theta over 2, except they used alphas instead of thetas. Awesome. That's great. Well, what does that mean for me? Well, that means we can now, you know, we can expand a little bit. For example, if I said, okay, here's an example. What is the cosine of 15 degrees. Ooh, okay, well, we solved and found the sine, but here's the cosine. Cosine of theta over 2 equals plus or minus 1. Oh, it's almost the same, except it's plus instead of minus. Anyhow, still glad I don't have to memorize it. But the cosine of 15 degrees is also cosine of 30 degrees over 2. And this is where my half angle comes in. It's the cosine of 30 over 2. So if this is 30, I'm going to plug it in here, and I'm going to get plus or minus the square root of 1 plus the cosine of the theta, which is 30 degrees, all over 2. So now I'm able to find the exact value for the cosine of 15. Again, 15 is the same as 30 over 2. This is my theta. This is my theta over here. I'm going to make it equal to plus or minus the square root of 1 plus, oh my, we're going way back. So katoa. Here's 30. Here's 60. That was 1 square root of 3 and 2. The cosine is adjacent over hypotenuse. Square root of 3 over 2, all divided by 2. Now out front, I have a plus or minus, don't I? First things first, what's my answer going to be?
Positive.
It's going to be positive, right? Because if I go back to my original question, I want the cosine of 15 degrees, and that's in the first quadrant. So the minus can go. This is just going to be a positive. And if I kept going, I'm going to get a common denominator up here. 2 plus square root of 3 over 2, all over 2. That equals, well, let's see what we have. Square root of 2 plus square root of 3 over 4. Because to divide by 2 is multiplied by the reciprocal. 1/2, 2 times 2 is 4. And I can even clean up my denominator. Square root of 2 plus the square root of 3 all over just 2. You notice the square root goes down there, but now I took the square root of the 4. All of those rules and building blocks that we learned along the way. Bam, we got the exact value. And I'm saying, whoop, whoop. Any of you saying whoop, whoop?
Whoop, whoop.
Whoop, whoop, awesome sauce. Oh, let's get you to try one. How about we do the tangent this time? The tangent of, 22.5 degrees.
Could you scroll up so I can finish writing?
I'm sorry. There you go.
No, you're fine.
Got it?
Yes, thank you.
So the tangent of 22.5 is the same as half of what?
45
Yeah,
minus
tangent.
2.
Excellent.
45 over 2, yeah.
Excellent. So now I use my tangent formula, and oh my, lions and tigers and bears. Oh, guess where this guy comes from? Sine over cosine, and the 2's end up canceling. But with a little bit of algebra, you know, we multiply the top by something, the bottom by something, like 1 minus the cosine, its conjugate, the square root, and oh, we have all these different forms. So this isn't so bad. I'm going to just pick the bottom one. This becomes the sine of 45 over 1 plus the cosine of 45. This becomes the sine of 45 over 1 plus the cosine of 45 degrees. We're rocking and we're rolling. I'm going to give you 30 seconds on your own to keep going with this, because watching me is easy. But if you catch a fish, yeah, then you can have catfish for the rest of your life. Maybe not Susquehanna River catfish, but you know, 45. Go back to my reference triangle. Again, I know my final answer is going to be positive. It's in that first quadrant. 1 squared of 2. All right, let's see. I have 1 over the square root of 2 over 1 plus 1 over the square root of 2. Ew. Not really ew. We've handled these before. These improper fractions or mixed fractions or whatever their crazy name was. I'm going to multiply by 1. And that version of 1 is square root of 2 over square root of 2. In the numerator, nice, 1. In the denominator, maybe not, so nice, square root of 2 plus 1. Close, except I now have to rationalize. Look at us using big words. Rationalize the denominator. Anybody remember how to do that? I do. Pick me, pick me. Anybody? What will I multiply top and bottom by? What
Is it
will I
root
multiply?
2 minus 1?
Excellent. And for bonus points for Gryffindor, what was that called? C word.
Conjugate.
Conjugate, excellent. I often think, should I make teams from everybody in the class and, you know, make Gryffindor and all of that like Hogwarts, but make up other names and then give points, and at the end of the semester, that team gets bonus points. Or would that not be cool? Yo, man, that wouldn't be cool. Okay, okay. Square root of 2 minus 1. I did the numerator. Double distribute. Square root of 2 times the square root of 2 is 2. And the reason we do this is the outer and the inner cancel. Minus 1. Hey, look at that answer. Square root of 2 minus 1. Exact answer for the tangent of 22.5. This is awesome. I know, right?
Wait, I'm sorry. Why does that cancel out? The root 2 minus 1 over 2 minus 1?
Okay, so I'm looking at just this denominator, multiplying by the conjugate. Square root of 2 times the square root of 2. That gives me the square root of 4, which turns into just 2. If I do the outer, I get negative square root of 2. If I do inner, I get positive square root of 2. So really, if I wrote this out, it would become square root of 4 minus square root of 2 plus square root of 2 minus 1. Square root
Right.
of 4 becomes 2. This guy and this guy cancel each other out. And then I have the minus 1. 2 minus 1 is just 1.
Oh, okay. Never mind. Yeah. I didn't do the 2 minus 1 in the denominator.
I was afraid that was what happened. I'm jiggy with it. Whatever that means. All right, well, let's do some other types of practice with this. What if I said something along the lines of the cosine of S equals 2/3, and it's in quadrant 4. Oh, Spider's Day's crunch. Yeah, quadrant 4, the cosine is positive. What is the cosine of S over 2? Well, if the cosine of S is in quadrant 4, so if S is in quadrant 4, what quadrant will S over 2 have to be in? If S is an angle, are we back? All right. So picking up where we left off, this is the cosine of S equals 2/3. If it's in quadrant 4, if I take this angle measure S and cut it in half, I know it has to be in quadrant 2. All spiders, cosine here has to be a negative answer. All right, it then becomes the square root of 1 plus the cosine of S, which I know is 2/3. So now we're into some heavy algebra. Negative square root of 1 plus 2/3 over 2. Did somebody clean that up for me? Or were you just waiting, hoping I wouldn't come back? Or you're just going to wait. I get it. All right, so now I have 1 plus 2/3 over 2, and I want to get rid of that 3, so I'm going to multiply everything in the top by 3 and everything in the bottom by 3. I'm going to get negative square root of 3 plus 2 over 6 equals negative square root of 5/6. And again, if I wanted to rationalize it, negative, I'd multiply top and bottom by 6, negative square root of 30 all over 6. Did anybody keep working and get that? Sometimes just lie makes me feel good. Yes, my Zoom went down. My students continued to work. They were so excited and so into it, and they got the right answer. All right. Let's do some more stuff with this. If I wrote plus or minus the square root of 1 plus cosine of 12x all over 2. Looks familiar? Yes, it does. If I go in reverse, what would this become? This is going to equal. I need that identity sheet. I need the one that's 1 plus, and it says whatever this is, it's going to be the same as that over 2, the cosine of that over 2. It's going to equal the cosine of 12x over 2. Cosine of 6x. Is that it? Yep. Man, we need to have easy ones like that on the test. I know, right? So far, so good, everyone. Patrick says yes. Charles says yes. We're all good. Okay. Let's put an end to section 5.6. 5.6, you are done. Did anybody show up late? We are at 13. Somebody else showed up. Nice. Who showed up?
I think I did.
Are you Kelsey? Sergio. Sergio. Thank you. Alexander, are you here? No Alexander. No Sammy. Huh. Surprised Kelsey's not here, or Alexander. Okay. Section 6.1. As I said, we're starting chapter 6 today. Not a lot of time in chapter 6 because a lot of it comes from what we're going to do here in section 1. And we'll do Wednesday and Monday, chapter 6, and then again we're going to have our test next Wednesday. Inverses. As soon as I see the word inverse, I'm like, oh yeah, Kool-Aid here, because I can remember doing inverses when I had something like y equal 2x plus 1, because y equals 2x plus 1. Well, first of all, let's take a look at this function. And I'm gonna say, all right, I have a function y equals 2x plus 1. If I plug in x, calculate. What do you get?
1.
Excellent.
1,
Keep going. I say 4. You say,
3.
I say 7. You say,
5.
yeah. And you notice I'm picking nice numbers because I didn't really feel like dealing with any fractions.
Yeah.
And you know, all along you're learning, oh, these are my domain and these are my range values and so on. And something that becomes kind of important and interesting to mathematicians is we're going to look at the inverse of those trig functions we've been talking about. So I'm going to go back to algebra, and this is what you learned in algebra. In order to find an inverse, right there, step number 2, to find an inverse, we switch the x and y. All right, so that means I'm going to take this equation and I'm going to switch x and y, which also means I'm switching the values for x and y. Okay, I'm switching the values. So if I was graphing this, I would have 1, 1, 4, 3, 2, 3, 4, 2, 3, 7, 5, and I'd have a line. So when I get ready to graph its inverse, I'm switching x's and y's because my inverse function over here, I switched the x and y. And you're going to say, well, what? It's not, yeah, it wasn't really important in college algebra, but it's a big area of study, part of a big plot that you need for trig. So, okay, so if I want to find an inverse, I'm going to solve for y. Again, that's a skill you learned way back that seemed extremely useless back then. 3x, because I multiplied by 3. I'm going to subtract 1, and then I'm going to divide by 2. And I came up with the inverse. That means if I took a list of those y values, 1, 3, and 5, and I plug those in, I'm going to do it real quick. I plug in 1, I get out 1. I plug in 3, I get out 4. I plug in 5, 15 minus 1 is 4, I get 7. So as you can see, I came up with an equation to find inverse values. I switched the x's and y's. What was my domain? Yeah, and some of you even remember a picture where you did this. Here was my domain. It went to the range. And then when I found the inverse, it took me right back to where I started. It had a one-to-oneness. It had a one-to-oneness. All right, cool. Kind of jiggy with it. Hit my first check mark up here. My 3 bullets. Bullets I always think are important. So quick review of what you hopefully kind of remember from college algebra. The domain and ranges switch. The x's and y's switch. So my inverse is here. And one of the things you learned was if this is f of x, my inverse was written as f with a little -1 up there of x. And that's the second bullet. An inverse function is f to the -1 of x, which isn't this. You know, -1 means to flip it, but this would be the whole function to the negative first power. This is special notation to represent inverse. And again, college algebra. So we're going to build on all of that you learned way back when, and we're going to apply it to functions. Now, one of the things is, you know, in order for something to be a function, it had to pass that vertical line test, right? Every x had only one y. And for it to be an inverse, the x's and y's switch. So instead of a vertical line test, it would have to pass a horizontal line test. All right, so we have both of those going. If I come down here and take a look at the sine function, whoop, whoop. Yes, it does. That's right. It passes the vertical line test. So this f of x right now is a function. And if I say, well, what about its inverse? You know, we're going to look, and I go, oh, nope, it doesn't have an inverse. The reason it doesn't have an inverse is it doesn't pass the horizontal line test. So what am I going to do? I'm going to have to do some restricting. Okay. I'm going to have to do something. Gianni, yes.
I remember, wasn't there a thing called like a one-to-one function where it passes both the horizontal and the vertical line test? Is that what it
Yes.
is?
And that's up
Okay.
here. Every x has only one y. And then I switch them. Every x over here has only one y. And it is that one-to-oneness, that term. Yep. Very good. So oh yeah, we did have one that went like this, and it was called y equaled x squared. But yeah, we had y equals x squared. But then when I went to find its inverse, I switched these two. I solved, and I got plus or minus squared of x equals y. And we're going, yeah, no, because this passed the vertical, but it didn't pass the horizontal. So what did we have to do? Well, if I wanted to find the inverse of y equals x squared, I said, nope, 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 nope. This is only going to work for x greater than or equal to 0. And we put restrictions on this. Which, and when I came down here, I noticed everything's positive. So this really became just y equals the square root of x. And again, we had these restrictions. Some of you are even going to remember, well, if I graph that, it looks like that, y equals the square root of x. And these two, what was this line? Anybody remember what that line is? Don't say it.
Asymptote.
Yeah, it's an asymptote. It's a line of symmetry. Okay, and this was the line y equals x. And if I graphed something and I graphed its inverse, they would be symmetrical over the line y equals x. So that's something you spent 50 minutes on back in algebra 2, you know, or college algebra, and we spent 10 minutes on it. But it was worth spending 10 minutes on it to knock the rust off, because we're going to use the same thing. So when I get ready and look at this graph, I'm going, yeah, this doesn't pass that. Yeah, yeah. So I need to restrict it. I need to restrict it. And I'm going to go, all right, here I go restricting it, but I want to hit all these values from -1 to 1. So when I get ready to restrict this, I'm getting out the big eraser and I'm going, yeah, no, 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 no. No. Oh man, am I erasing stuff? Chewbacca. I'm erasing all of that. Now I left it on there lightly so you can still see it. So now all I have is from -1 to 1. And I hit all those values. And that little segment of y equals the sine of x is what I'm restricting. Just like I restricted y equals x squared. Okay, so I did a restriction on this. Now, if I want to find its inverse, I'm going to start by doing this. Okay, I'm going to cheat, and I'm going to say, well, x equals and y equals, and this guy right here at -pi/2, I was at -1. And at 0, I was at 0. Whoop, whoop. I can put that bad boy in right there. I went all the way to pi/2, and that got me to +1. All right, so this graph is going to be +1 and -1. This time, because I'm going to switch these to do the inverse. At -1, I'm down here at -pi/2. At 0, I'm at 0. At +1, I should be all the way up to +2. So I picked a couple of points to help me graph this bad boy. I'm so excited. Now, if I took the line y equals x, and I flip this over the line y equals x, I'm going to have a graph that looks like, I hope I don't screw this up, to there, and then to here. I think, yeah, that doesn't look so good. That doesn't look, oh, okay, so here's what I'm going to do. I'm going to get a little help, because I think I'm pretty close. I just needed to pick some more points in here to get the exact, but I think it's going to be, so what do? Well, what every good student does, I go ask the Google, google.com, and I'll share in a second, and I'm going inverse trig functions, and we want to see what they look like, because if I click images, and where are my graphs? Let's see what we can find. I'm finding a good one. Hopefully some of you are doing the same. Inverse trig function graphs. I had a sheet some time ago. Let me see if this is a good one. Notes. I'll put helpful stuff up. Yeah, they're not so good. I'm going to keep doing the Google. The picture was good, but all right, this one doesn't look too bad. As soon as it comes up. This site can't be reached. Well, why the heck not? I'm just going to share that part. Oh, Norton has blocked an attack. Well, that's not good. Come on. And I hit share. Okay, can you see that? Can you see that?
Nothing on the screen now, Professor.
Yeah, not yet.
All right, stop sharing. I'm going to share again. Share screen, click, and click. Can you see it?
Yep, now we
There
can
we
see
go.
it.
Okay, so yeah, taking a look at, I don't know if you can see this first one from -1 to 1, from down to -pi/2 up to +1. And yeah, we got that sort of shape. That almost looks a little bit like my tangent. Oh yeah, looks a little bit like tangent. You notice the domain from -1 to 1. The range, -pi/2 to pi/2. If I stop sharing, I come back to my screen, but there it is. Yep, it goes like this, goes like that. Okay, now, here's where this is going to become really important and what we need to know. If I thought of my unit circle and I want to put this graph only on my unit circle, okay, this graph only on my unit circle, I'm going to draw my unit circle. Here's 0, here's pi, here's, pi/2, here's pi, here is 3 pi/2. Right? So I'm thinking about the unit circle, and this, so if I took my values, I'm looking at the values from -pi/2, because it's right here, to +pi/2. I'm taking my values from -pi/2 to pi/2. So don't think about this graph anymore. Think about this graph. Y equals the inverse sine of x. This is now the one on a unit circle. So if I'm going to work with this function and I have a positive value it's gonna be here in quadrant 1. This is a little bit like that all spiders taste crunchy kind of deal. So if I have a positive value for my inverse trig function, it's gonna be in this first quadrant. If I have a negative value, it's gonna be in the 4th quadrant. It's a little, that's gonna be foggy the first time you see that, but we're gonna talk a little bit more about it. If I took these values, my domain from negative pi over 2 to pi over 2, and put it back on my unit circle, I'm thinking of this region. And the reason is when we start working with these, if the value needs to be positive, it's going to be in the first quadrant. If the value needs to be negative, it's going to be in the second quadrant. So I have a note down here, quadrant 4, which will be for my negatives, quadrant 1, which will be for the positives. And again, you're going to see that in a couple minutes. The cosine, we know how the cosine goes. Again, I'm going to do my restrictions, and I'm going to only use this much. Again, there's that term I'm going to use for one-on-oneness. This is now going to be 1-to-1. Every x has only one y value, and when I switch them, every y has only one x value. And if I thought I want to take a look at the graph here, let's see, I pick some points. I have 0, pi over 2, and pi. 0 is 1, pi over 2 is 0, and pi is -1. So if I come over here, I have -1, I have 0, I have +1. At -1, I'm up at pi. At 0, I'm at pi over 2. Well, and yeah, at 1, I'm at 0. So again, this graph, you know, if I drew the line y equals x and flipped it, that's what I would get here. And I think this one goes something along the lines like this. Then if I picked more values. Now, the most important thing is right here. If I took a look at this guy on the unit circle, okay, it goes from 0 to pi. So on the unit circle, this is y equals the inverse sign. It goes from 0 to there, to there, to there. So all of the positive values are in quadrant 1. This time, instead of the negatives being in quadrant 4, all of the negative values are going to be in quadrant V. No, in quadrant 2. Going to make this make a little bit more sense later. All the positives are in 1. This time the negatives are in 2. And the reason I don't have all spiders taste crunchy is because remember I restricted my domain. Yeah, so I wanted to spend a little extra time on this one. Tangent. Let's see what we got. X, Y. Uh-oh, I know. There's an asymptote there, and there's an asymptote there. So if I come over here and say, hey, there's pi over 2, here's negative pi over 2, I'm going to draw these asymptotes. Because what was once vertical is now horizontal. I have 1.00, which is good. I know that. Tangent of 45 degrees is 1. So we can go back and forth that way. But if I flip this over the line y equals x, if I flip it, I get something that looks like this. So this guy actually goes on and on and on forever. Why? What's this guy's domain? What's his range? His range is all real numbers, which means this guy's domain has to be all real numbers. Ah, back and forth, back and forth, back and forth.
Uh-oh.
Uh-oh.
Yeah, it froze again.
Oh, no. No, no. I see my hand. Come on,
Yeah.
baby. Don't
We
die.
can see you.
You can see me
Hear me
now.
now.
Yeah, we can see you.
Good. Did you get that whole, if the range here was all real numbers, the domain here is going to be, because we switched the X's and Y, all real numbers. So this guy's kind of interesting, the inverse tangent. Okay. Again, if I put him on a unit circle, here I go again, this negative pi over 2 to pi over 2. So the inverse tangent is going to be like the inverse sine was, where all of my positive values are quadrant 1, all of my negative values are quadrant 4. Again, hang in there with that, because we're going to do an example or two, and hopefully it's going to make a little more sense. Okay, so we have the inverse functions. And again, I may have to go to Google, let's go Google, and see if I can find something I can print out that has these on there all nice and pretty, and I'm ready. Uh-oh. I see verbiage here, arctan. Well, let it be noted, the arctan of X is another way of writing the inverse tangent of X. Interchangeable lingo. The inverse tangent can also be called the arctan. All right, so I want to solve this. I'm going to solve this. I'm kind of excited about it. I'm going to solve this, and I'm going to solve it this way. The arctan of 1 is the same as the tangent of theta equals 1. I basically bring it over. I take the tangent of this side and the tangent of this side, and the tangent cancels out the arctan. Tangent of theta equals 1. I know that theta. I know you theta. That theta is
45.
excellent. 45 degrees. 45. So if I put that in a calculator, what? Yeah, if I put that in a calculator on clear, you can do this on the calculator. Yes, I can. I want the arctan of 1. First thing I'm going to do is make sure my mode is in degrees, which it is because I want a degree answer. And I'm going to get out of there. Second, quit. I'm going to hit the inverse tangent, and it's above tangent. Second, tangent of 1. Oh, please work, please work, please work, please work. 45 degrees. Yes, exactly what I was talking about. Nice. Nice. So if I have the inverse secant, well, we didn't talk about it, but if the other 3 work, that's going to be the same as the secant of theta equals 2. Yeah, I don't know what that is. Let's keep going. I know the sequence, the secant is 1 over the cosine of theta. And if I multiply by the cosine, I divide by the 2, I get cosine of theta equals 1/2. This is positive, so I know it's in quadrant 1. And oh, yeah, I just can't. The cosine is 1, 2, adjacent over hypotenuse. What's that make this side? Square root of 3? Oh yeah, that's my 60. Nice. Theta equals 60 degrees. So you notice now I'm getting angle measures for answers when I use the inverse. Theta equals the angle measure of the inverse secant of the value 2. So far, so good? Yeah, buddy. Okay, I need to find the exact values. I know for a fact that this is an angle measure. So the sine of this angle measure is what I'm trying to find for an answer. Say that again. I know that the inverse tangent of 3/2 equals an angle measure. I know that the tangent of theta equals 3/2. Well, quadrant 1, I'm going to go tangent 3, 2. What? Here's theta. What's the hypotenuse? That's that line right there. Yeah, I know it's that line right there. What's the value of the hypotenuse?
Root
The square.
13.
Yep, excellent. Square root of 13. So this inside of here is the angle measure. The angle measure is this triangle right here. That's what all of this told me. That's my triangle. So if theta equals this, next thing I want to do is find the sine of theta. I feel like I'm out far today. Does that help a little bit? I need to find the value for the sine of theta. Okay, 2 miles, good. Opposite over hypotenuse, 3 over square root of 13, which is going to equal 3 root 13 over 13. Nice. And I'm telling you, this is going to be on the test. And somebody's going to try and do this on their calculator and then take the sine of that, and they're going to get some crazy answer in there. And nope, 0. I want you to find the exact value. Show that you understand this represents an angle measure, not triangle, and so forth. And I'm going to give you a chance to work on this one. And the tangent, I know that's just a smudge from the other page. The tangent of the inverse cosine of -5 over 13. The tangent of the inverse cosine of -5 over 13. So I know the inverse is always an angle measure. So I'm going to say, hey, let's let that equal to theta. And that's a 3, -5 over 13. Giving y'all some time to work on that. So the cosine of theta equals -5 over 30. Oh, the cosine is negative. When I'm dealing with inverses, I need to know which quadrant, because going back to old school, all spiders taste crunchy. If I'm working with the cosine, it's a negative. It's either the second or the third. But this is where what I was talking about earlier, if I took those values and looked where are they on the unit circle, the positives for inverse cosine were quadrant 1, the negatives were quadrant 2. So now when I want to draw this triangle, I know I have to put it in quadrant 2. And that's what all that extra conversation I was having about with the positives and the negatives. Where are my negatives? The cosine is quadrant 2. The sine and the tangent were quadrant 4. So I'm going to draw it over here. -5, 13. This is my theta right in there. Didn't leave myself much room on this. I believe this was going to be a nice number. It is one of my Pythagorean triples. Some of you in high school had to memorize them because you had 180 days and we have 28 days.
12.
12, very good. Tangent, opposite over adjacent, -12/5. Final answer. You are now a millionaire. So again, I come back over here. When I did the cosine, I knew my negatives were in quadrant 2. Well, sine and tangent, my negatives were in quadrant 4. All right, so this says exact values for both of these problems. This does not. Let's see if we can calculate this on the calculator since we already have it out. I'm going to do some work first because, yeah, so the cosecant of the inverse cosecant is that. And if that equaled an angle measure, so the cosecant of theta, okay, see you, Julian. The cosecant of theta equals -3 kind of deal. You know, the cosecant of theta equals -3. And yeah, because I can't put the inverse cosecant in. But oh wait, this is 1 over the sine of theta equals -3. Do we agree with that? And if I flip both of these, I get the sine of theta equals -1/3. And now I send the sine over, theta equals the inverse sine of -1/3. Again, I didn't give myself enough room. I couldn't do this cosecant, but yeah, that works out. That's the same as the inverse sine of its reciprocal. That's -1/3. So I can do that on the calculator. Answer wants it in radians. I'm putting this on. How you doing? There it is. Hopefully you can see it. Not the best today. Maybe I'm too close. Didn't matter. All right, so I want to do mode first, come down and get in radians. Get over there. Get in radians. Second quit. Now I want to find the inverse sine of -1/3. Second sine. Down on the bottom here. Down on the bottom is where down here. And well, way down there. That's my -1 divided by 3. Don't use the minus sign. If I hit enter, -0.339, that would round up, -0.340. -0.340. Okay, so some things I just learned doing this last problem. Theta equals the inverse tangent of 1 over -3.541. Again, it's the same work I did over here. The cosecant to the inverse sine, I can flip them. Cotangent to the inverse tangent, I can flip it. Want to find the answer? First thing I need to do is go back to degrees. Second. Well, I don't want second. I want mode. I want to go back down and make sure my calculator is in degrees. Now I want to find, let's see, calculate the inverse tangent. Second tangent. 1 divided by that -3.541. -15.770. Can anybody confirm or deny that? I'm in degrees, so I should probably put a little degree up there. Because I wanted to find degrees. Negative 15.77 degrees. All right, that was a lot today. That was a lot today, but what we did today is really setting the table for the rest of chapter 6, working with these inverse functions. And we're going to be able to cover, I believe, 2 sections on Wednesday and then the rest of it next Monday. But are there any questions? That's a little better. Why didn't I do that earlier? Are there any questions? Is anybody still awake? I know a couple people are. Yep. Okay, you know when my office hours are? You should be working on chapter 5, almost ready to start chapter 6 homework. I believe the chapter 5 quiz is coming up. And hopefully some of you got after that assignment sheet over break. Got a good start on that. All righty. I will see you all on Wednesday. So
Have a good one.
have a good day.
A good day.